Hi there, I have a nice double sum problem for you, and let's see how we can do it. So here I have two variables, k and n, and so let's try to first evaluate this inside sum. Here, for this sum, k is behaving like a constant because it depends on n. So let's just take this and put it here, because I can just do that. I can't take it here, but I can take it here. And now let's try to find this sum. So n is from 0 to infinity, n factorial over n plus k plus 2 factorial. Okay, I have a weird looking sum with factorials. What would be nice? Well, of course, to have it telescoping. If it was telescoping, meaning that if this was in the form of an plus 1 minus an, for example, n is from 0 to k, like almost all of the terms would cancel. I would have only the k plus 1 term and also a0 minus a0, and it would be very easy. So this is the best case for any series. And well, now, so of course this would also be from 0 to k. So I'm just trying to write this thing as a sequence, but just the difference of two adjacent terms. Can I do that? So let's make an attempt. Here it's not easy to see. You can try to multiply it with some stuff, divide, but if I did it with this way, I think it wouldn't be convincing because it's very hard to see. Maybe it comes with practice, but I will just do this from scratch, okay? No bullshit. So, well, let's make a horrible guess and say an. I'm just gonna make a one guess, and then I will figure out the correct guess, okay? Let's make a horrible guess and say an is just this thing, n plus k plus 2 factorial. Well, why am I picking this thing? Well, first of all, to show, and second of all, it's not that stupid to pick something in similar form, because, well, I will have some stuff, and when I have the difference, there is a chance that the denominators and nominators will simplify, and I will luckily get the same thing. So let's just calculate an plus 1 minus an for this thing. So this will be n plus 1 factorial over n plus k plus 3 factorial minus n factorial over n plus k plus 2 factorial. Okay. So if I multiply this, well, I can notice that n factorial and n plus k plus 2 factorial is common. So if I do this, I will get n factorial n plus k plus 2 factorial is common. And for this one, I need only n plus 1. And for this one, I need n plus k plus 3 minus n minus k minus 3. So meaning this thing is just minus k minus 2. Let's just delete this and say minus k minus 2 over both of these. And I can also notice that I have this and this at the denominator, but I also got this at the top. So which means I'm at the correct path actually. So I will just also delete this. Oh, I delete too much. So let's say n factorial and n plus k plus 3 factorial. So this is what I wanted to get, and this is what I got. What is wrong here? Well, first of all, this constant here, k, like I said, k is a constant for this sum. So I don't care about this thing. I can just divide an by 1 over minus k minus 2, and I will be okay. This is not a problem. But the problem is I got n plus k plus 3 at the denominator instead of 2. Well, I can guess that if I actually pick an as n factorial over n plus k plus 1 factorial, well, these calculations will almost be exactly the same, but this time I will have n plus k plus 2 factorial at the denominator, and I will just get a constant k term, but I can just divide by that. and I will be good. Okay, so I made a stupid guess, but I saw that I'm close. So now let's calculate an plus 1 minus an. Well, I will cheat a bit here because it will be almost same. So I will have n factorial. And what this thing was, n plus 1 minus n plus k plus 3, but this one will just be n plus k plus 2. So this time it will just be 1 less, okay? This will be minus k minus 1. You can do the algebra, and n plus k plus 2 factorial. Perfect. So instead of picking an as, well, if I picked it 1 over k minus 1 over k plus 1, then I also wouldn't get this thing. And it would be perfect, because this is what I want. Okay, so this is my guess. So what this means is that, let's go back and put this in our question, okay? So I wanted to calculate the sum, and I said it will just be an plus 1 minus an for the finite part, okay? Let's try to evaluate first the finite part, and I will see what happens when it goes to infinity. So I figured that this thing is literally equal to an plus 1 minus an for this specific sequence, okay? And so, well, here minus 1 over k plus 1 is a constant. So I will just throw this here in the end. I will just consider that later. Or I can just write it like this. Minus 1 over k plus 1. This is a constant. And so when I do this, well, I know that it will just be an plus 1. Well, wait, I think I won't have this. Let's just do this. So for that an, I will have this. And now when I calculate this, all of the middle terms will simplify, and I will get ak plus 1 minus a0 from 0 to k. Okay? And what is ak plus 1? So I will just put n plus 1. And I will also put 0. So when I put 0, let's just put them here, and then I will substitute them at the top. So when I put n is equal to k plus, when I put n is equal to k plus 1, I will get k plus 1 factorial over 2k plus 1 factorial. Wait, 2k plus 2 factorial. And I also have this thing, minus 1 over k plus 1. So this is for n is equal to k plus 1. And so this will be one of my terms. And so no matter how many k's I add, this will be my last term. And also when I take k goes to infinity, of course, I mean, here I have k plus 1 and 2k plus 2. Of course, this is bigger than that. And this has a lot more k's than this one has. So this will just go to 0, obviously. And when I put k is equal to 0, I'm going to get 0 factorial over k plus 1 factorial minus 1 over k times, of course, minus 1 over k plus 1. Okay, so this is all I'm going to get. This is my a0 term. And factorial is just 0 factorial is just 1. This is just minus 1. So I'm just going to get a minus 1 over this thing. So this sum is equal to, well, let's say this will converge to, because ak1 goes to, this one goes to 0, and this one I just showed that. So what did I write? I think I already forgot. Minus 1 over n plus 1. I will cheat. K plus 1, k plus 1. Yeah. K plus 1 factorial times k plus 1. So this is equal to this sum. Okay. So I wrote it partially. Like I said, from 0 to k, it's going to be equal to this thing, and this will converge to this thing. So I just calculated this inside part. Okay, perfect. So now let's substitute this here, which will give me something much simpler. Let's do it like this. So I'm going to have k from 0 to infinity, the sum. So I have k factorial. I already factored this up in the beginning. Then I'm going to have a minus. Yeah, I don't have it because I said minus a0. But here this thing was plus a0, so this will be a plus. So my sum is gonna be so this will be plus. I'm gonna have my k factorial from here, and also this thing, k plus 1 factorial, k plus 1. Perfect. And now what happens? Well, I can just simplify. K plus 1 factorial is k plus 1 times k factorial, so they will simplify nicely. K from 0 to infinity. It will be 1 over k plus 1, which is k plus 1 squared. And well, this is actually a very famous sum. This is k from 1 to infinity, 1 over k squared, or let's put n to make it even nicer, because this is the answer of the Basel problem, which is pi squared over 6. I still didn't make a video about this sum. This is one of the best results in math, I guess, one of the best series. And so this is equal to this series, and this is our answer.